In this lesson, we are going to be talking about multiplicity in polynomials. All that it really is, it's a fancy word, but what it actually just does is it helps us to know what the graph's going to look like. Okay, so let me show you with an example. So let's say, for example, you had this equation and you factorized it, and these are the brackets that you just got. So we know that from these brackets, we could actually go and solve for the zeros. You know, the zeros are the places where the graph touches the x-axis. Your teacher might call them roots or the x-intercepts, but we can solve those from those brackets by just saying x minus 1 equals to 0, or x plus 2 squared is equal to 0, or x take away 2 is equal to 0. So if we had to go solve the first one, you would get x equals to 1. If we had to go solve the second one, you would take the square root of 0, because you would square root both sides. You could say plus minus, but plus minus 0 is just 0. So for that one, you're going to end up with x plus 2 on the left equals to 0, and so x would be negative 2. Now, okay, so we've solved that one, and then you'd have to solve this one, so, or x is equal to 2. So these are our three x-intercepts. So if we had to go put the graph now, what do we have? We have x equals to 1, so there's x equals to 1, x equals to 2, there it is, and x equals to negative 2. Okay, but that's not enough to help us know what the graph looks like. So in the previous lesson, I showed you how to work out the end behavior to see whether the graph goes down or up on that side, and then whether it goes up or down on that side. Okay, so let's quickly do that. Now, if you remember that lesson, what I told you to do was, if you had the equation, if you knew what this equation was, you always had to look at the highest power. That's all that you had to do. So if we had to go get the highest power from this, we know that it's x multiplied by, now this is x to the power of 2. Okay, so if you had to, I'm not going to go multiply the whole thing out, it's not necessary, but this one multiplied by this one, which is already to the power of 2, would give you x to the power of 3, and then if you multiplied that with this, you'd get x to the power of 4, and it would be a positive, it wouldn't be a negative. Okay, so if you wanted to see what it does on this side, you would plug in infinity, because this is infinity. You can think of it like that. And infinity to the power of 4 is going to be a very big positive number. So that means it's going to go up on this side. And then if you had to make x negative infinity, that's still going to be positive, because a negative and a negative and a negative and a negative is still going to be a positive. So here on the left-hand side, it's also going to be going up. Okay, so we know that at least. We know that our graph is doing that at the end side. But that still isn't enough to draw this graph. I mean, there's still different options of how this graph could go. Like, for example, it could go there and turn and then go down and then go up like that. Or it could maybe go right through and then turn there. You know, we don't know exactly. It could, as I said, it could go through here, turn there, or it could go turn there, go through there, and then go up. So there's different options of what might happen. So this is where we need to look at multiplicity. So what you do to work out the multiplicity is you look at each of these brackets and you look at the exponents. This one would be a 1, this is a 2, and this is a 1. Okay, if it is an odd number, then the graph is going to look like this, either like that or like that. If it is a even number, then the graph is going to be turning at that point. It's going to be turning either like that or like that. Okay, now if we had to look at this one, which is, if you had to solve this, this is x equals to negative 2. So that's this one over here. We can see that that has an even power. Okay, for its multiplicity, it's got an even power. So it means it's turning either like that or like that. So we don't know if it does this or if it does that. But actually we do, because it has to connect with this part. So the only one that makes sense is that it does that. It wouldn't make sense that it does that, because then it's going down. But we learned that the end behavior, it's going up. So our graph definitely does that. Okay, then we know that it would have to somehow turn eventually. Why? Because it has to come back through here. So we now know that it's going to go through the 1 like that. Then it's going to have to turn, of course, because it has to go through here eventually. Now, if we look at this one, which is this one over here, it's x take away 2. When we solved that, we got x equals to 2. So it's definitely this one. If you look at its multiplicity, it's a 1. So it means it's going to go through. It's not going to do this. It's not going to do that. It's going to go through. And then, of course, it's just going to connect to this part over here. And so that is what that graph would look like. Yes, we don't know exactly what this point is, and we don't know what that point is, but that's not that important. We just want to know the general shape. Let's do another example. So here with this one, we can quickly go do a little sketch. So we know that if you had to solve this one for 0, you would get x equals to -3. So that's over here. If you had to go solve this one, you would get that x is equal to 4. So that would be over here. And then if you had to go solve this one, you'd get that x is -2, which is over there. Now, that doesn't give us enough information to be able to draw the graph. So what we need to look at next is the end behavior. We need to know if it's going to go down or up, and then up over here or down. Okay, that's what we need to go work out next. So we need to find the highest power. So that's x, and then this is x to the power of 3. So it's x times x to the power of 3, which is x to the 5. What that means is that if you had to go multiply all of these brackets together, you would get a whole lot of stuff, but the highest power would be x5. You would be like, I don't know, x5 take away 3x4 plus 2x cubed minus 6x squared plus 2x minus 8. Who knows? That's just making it up. But to work out end behavior, you only have to look at this highest power. Okay, so to work out the end behavior on this side, you plug in infinity. So what would infinity to the power of 5 be? Would it be positive or negative? It would be a positive number. So that means it's going up. Okay, whenever it's a positive number, it goes up. If it's a negative number, it goes down. If we had to then plug in negative infinity in a bracket, then you would have 5 negatives. It would be negative infinity times negative infinity times negative infinity times negative infinity times negative infinity. 5 negatives is going to give you a negative. So if you get a negative infinity, that means going down. Positive means going up. Negative means going down. And there we go. And the reason this is on the left-hand side is because I'm using negative infinity. It's the negative side of the graph for the x values. Okay, so now at least we have a good idea of what the graph's going to do. But we still don't know enough. We don't know if it's going to do this, or maybe it's going to go right through. We don't know that. Or maybe over here, it's going to go through, or maybe it's going to turn. So we need to still work out the multiplicity. So to do that, let's start with the 3. You look at the exponent. Okay, it's a 1, so it means it goes through. Remember, if it's an odd number, it goes through. So it goes through. So it looks like that or like that. If it is an even number, then it turns either like that or like that. Okay, so it's going to go right through. So let's do that. There we go. Now, if you look at the -2, it's an odd number. I know it's positive 2 here, but if you had to solve it, it's -2. So this is an odd number, so it means it's going to go through, okay? So it means that it's going to do this, it's going to turn, and then it's going to go through. It's not going to do this. It's not going to go like that, okay? It's going to go through. So it goes through there and through there. Perfect. Now we know that it's definitely going to turn again. Why do I say that? Well, it has to go through here as well. So let's see. It's going to go through. Now, it could turn down, but I don't think that's what's going to happen. Why? Because then it would never get to this. So it's probably going to go through here as well. But let's just make sure. If you look at the multiplicity, so you look at the exponent, it's a 1. And if it's an odd number, then it goes through. So it's going to go straight through like that. Here's our next example. So what we'll quickly go do is just draw a basic little graph. If you had to solve this for 0, so x take away 5 equals to 0, you're going to get x equals to 5. So let's go put that as our little 0, so 5. If you had to solve this one, you would say x take away 4 is equal to 0, so that's over here. And then if you had to make this equal to 0, you'd get x equals to -2. So that's going to be over here. There we go. Now, let's quickly go check out the end behavior. So remember, I did make a video on this in the previous lesson. So to work out the end behavior, we just need to get the highest power. So this is x to the power of 2. This is just x. And this is x to the power of 3. So if you had to go multiply all of these brackets together, this would be x2 multiplied by x3, which gives you x to the power of 6. Okay, so we'll use that to work out the end behavior. So to work out on the right-hand side, use infinity. So is that going to give you a very positive number or a very negative number? Well, that's a very positive number, so it's going to be up here. Okay? If it's negative, then it goes down. So to work out the negative side, which is on this side, you use negative infinity. Now, if you have 6 negatives, right? Negative infinity, negative infinity, negative infinity 6 times, that's going to give you a positive. Like, if you have an even number of negatives multiplied together, then it gives you a positive. So if it's positive, it goes up as well. Okay, so that's what the end behavior of this graph looks like. We're going up on both sides. Great, but that's not enough to know how to draw this. We don't know if maybe it's going to turn here and then go through there, or maybe it's going to go through there and then turn, or maybe it's going to go through, and through. We don't know. So we need to go look at multiplicity. So for the -2 part, we know that we're going to get that from there. It's an odd number. Odd number, if it's odd, then it goes through. Okay, so let's make it go through quickly. So there we go. Now, okay, so we've done that. Let's look at this one. X minus 4, it's an odd number, so it goes through. So it means it's going to turn, and then it's going to go through. If you look at the 5, it's a 2. So that's an even number. If it's an even number, then it turns. So that means it's going to go like this. It's going to turn. And that makes sense, because if it didn't turn, and it went through, then it would never connect to this. So that would be pretty awkward. So it turns like that.